You're listening to the N2K Space Network.
With over 8,000 threat hunters analyzing over 65 trillion signals daily, Microsoft works tirelessly with the federal government to keep our nation's data secure. This 30-year-plus partnership is driving mission innovation that is secure by design. Whether optimizing your existing defenses or tackling advanced threats with AI, Microsoft gives you the intelligence and the automation you need to defend at mission scale. Let's work together to stay ahead of emerging threats and secure your mission anywhere. Learn more at aka.ms/fedcyber. That's aka.ms/fedcyber.
May the 4th be with you, and also with you, started as a phrase that spun off from the, I'm sure you all know it, the popular Star Wars movie series. Even though the holiday was not created or declared by Lucasfilm, many Star Wars fans have chosen to celebrate the holiday. So it only makes sense that for our deep space today, that we mark this popular sci-fi date and look beyond our known space into the unknown. Welcome to T-Minus Deep Space from N2K Networks. I'm Maria Varmazes. Our sister podcast, the Spycast, hosted by Curator of the International Spy Museum, Andrew Hammond, spoke to Harvard Astrophysicist Avi Loeb. Now, Avi is an Israeli-American theoretical physicist who works on astrophysics and cosmology. He's also a best-selling novelist, and in 2012, Time magazine selected him as one of the 25 most influential people in space. Andrew spoke to Avi Loeb about his theory of what is out there in the universe.
So 1952, the assistant director at the CIA for the Office of Scientific Intelligence sends a memo to the director of the CIA. The issue is flying saucers. Whether or not there are security implications in the problem of unidentified flying objects, and what further investigation and research should be instituted and by whom. So that actually made me think of your book, Avi, because in your book you discuss that quite often interstellar issues or relations are viewed through the lens of security or by the military. And also you say that the research should be something that's done almost as a species rather than through the lens of a particular nation. I just wanted to briefly get a primer on what led you to start exploring interstellar intelligence. I know that you were at Harvard, this is your area of research, but tell us what led you to write this book, and we can maybe pick up on some of the connections between the intelligence agencies and your field of research.
Yeah, so I'm an astrophysicist, and I'm pretty much interested in everything that the cosmos has to offer. And with respect to the first thing you said, I'm usually thinking about an analogy with the North Sentinel Island. That's within the Indian chain of islands in the Bay of Bengal. And the islanders constitute one of the few remaining hunter-gatherer tribes on Earth. They have no contact with the more advanced culture that we live in. And in fact, India forbids visit to this island, and the Sentinelese resist attempts for contact by outsiders. In 2004, there was a major earthquake that generated a devastating tsunami, and the Indian Coast Guard flew a reconnaissance mission to the island, and the Sentinelese emerged from the forest and shot arrows at the incoming helicopter. And what I'm worried about is that this is a metaphor for the way we behave. We think that, we are attacked every time there might be a hint for a neighbor in our cosmic environment. And the suspicion that we may be attacked brings the subject to the realm of the Director of National Intelligence, the military, and instead it should be the focus of scientists. Because anything that lies outside the solar system is my day job. It's not the government's day job. Their day job is to worry about national security. But anything to do with the universe at large is not a matter of national security for several reasons. The way we split the land on this rock that we were born on, which is a relic from the formation of the sun, is completely irrelevant to these visitors from far away. They started their journey probably billions of years ago. Time is measured in billions of years in the universe, and we existed only for a few million years as the human species. So, the border between Russia and Ukraine is invisible when you get to the distance of the moon. And not to speak about wherever anything came to the solar system from far away. They didn't have us in mind. They don't care about our local affairs. It has nothing to do with a particular government or national security concerns. It has to be knowledge that is shared by all humans, the way science is handled. And that's my main point, that if the government has any information, has any materials, I would very much encourage them to share it with scientists like myself for two reasons. One, they are not really geared to doing scientific research. I mean, they might think that it perhaps would bring some benefits to national security, but that's a very narrow-minded view. And the second, the scientists like myself, I've been working in astronomy for 40 years. I have a perspective on everything the cosmos has to offer that we know about, and I can help them figure out the nature of these objects or materials. Now, I'm not naive. I don't expect the government to come forward if they have anything. Maybe they don't have anything. Maybe they just saw unusual things that adversarial countries launched based on technologies that we are not aware of. But so I'm not waiting for the government to figure it out or tell me what they have. Instead, I have started the Galileo project at Harvard University 2.5 years ago, where we monitor the sky 24/7 at all times with a new observatory. You have to understand that astronomers look at a small region of the sky, usually with existing observatories, and they train the telescope on very distant sources of light. They ignore anything that flies overhead. And we had to build from scratch a completely new concept, a new design of an observatory that looks at the entire sky at all times. We have machine learning software that analyzes all objects and tries to figure out whether it's a bird, a natural object, or maybe an airplane, a balloon, a satellite, or perhaps a drone that humans made. And the key question is whether 1 out of 1,000, 1 out of 1,000,000, perhaps came from somewhere else. The government really cares about 99.9999% of all the objects. If they figure them out, they are happy, as long as it's not any national security risk. I care about the very rare object that has nothing to do with humans here on Earth, and therefore my job is complementary to that of government. And the second part of the Galileo project is aimed at finding materials from interstellar meteors. These are objects that collide with Earth, and based on their high speed before the impact, we can tell that they came from outside the solar system, that they were not bound to the sun. And the first such object was discovered by US government satellites a decade ago, exactly a decade ago, on January 8th, 2014. And I led an expedition to the Pacific Ocean where this meteor exploded 20 kilometers above the ocean surface. And we went there to scoop any related materials left over from the meteor, any molten droplets from it that landed on the ocean floor. This is roughly a mile deep. And we went across a region that is 7 miles long with a ship. There were of other 28 people on the expedition team, the best people in the world, navigators, engineers, scientists. And we came back with 850 molten droplets, out of which a few percent, up to 10% of those molten droplets have a composition that was never reported before for materials from the solar system. We analyzed 60 elements from the periodic table, and they appear to have concentrations that are not resembling what you find either on the surface of Earth, the Moon, Mars, and the asteroids. So we say, well, maybe we have evidence that this object indeed, aside from its high speed, came from outside the solar system. And it was moving really fast. So altogether, what I'm saying is, this is a subject that can be examined scientifically. It has nothing to do with conspiracy theories. It has nothing to do with people reporting about their personal experiences. It has to do with using instruments to measure the properties of objects that arrive to the solar system from outside. And, maybe among the rocks that we are used to in our backyard, we will find a tennis ball that was thrown by a neighbor. That's my hope.
Just a couple of quick follow-up questions, just for our listeners who may be a little rusty on some of the terms. So what's the difference between a meteor and an asteroid?
Okay. So a meteor is an object that happens to collide with Earth. It just has a trajectory that crosses the Earth's trajectory. They happen to arrive at the same point at the same time. It's just like you are running in the street and bumping into another person, okay? Of course, the smaller the object is, the more common it is. So we have many more, like centimeter-sized objects collide with Earth, every 15 seconds or so. Very big objects like the size of Manhattan Island, a giant rock of this type, collided with Earth 66 million years ago. And that's why the dinosaurs are not around anymore. So when something giant like that collides, it has devastating consequences. It raises a lot of dust and creates a nuclear winter, similar to a global atomic war. That's what the dinosaurs suffered from. They didn't have telescopes to monitor the skies. And then asteroids are just rocks that are floating in space that do not collide with Earth. They are left over. They are sort of like Lego pieces that were left over from the construction process of the planets. So the solar system started as a cloud of gas and dust, and it was rotating, spinning around the sun, and the debris left from the formation of the sun ended up making the planet. So it started as dust that settled to the plane of this disk that was rotating around the sun, and then dust particles coagulated and made bigger particles, and those particles made even bigger particles, and so forth, and eventually ended up with rocks and boulders and rocky planets like the Earth is. But the process was not entirely efficient, and there were some rocks left behind, sort of like unused Lego pieces. And also there were some objects that were destroyed as a result of collisions. And so you end up with rocks in the solar system. There is the asteroid belt that may very well be a result of collisions between bigger objects. And those rocks are all around us, and every now and then, one of them collides with Earth, becomes a meteor, but others are mostly floating freely in space.
So I'm just thinking about the way that the intelligence community makes sense of phenomena that's out there in the world. So we're thinking mainly about planet Earth. So there's measurements and signature intelligence where they look at things like energy, the motion, reflection, radiation, all of these other types of features that you can pick up from phenomena in the universe. There's imagery intelligence where they're capturing imagery of things that exist, or they're doing signals intelligence. They're trying to intercept communications. Sometimes that can be human to human, sometimes it can be machine to machine. So all of those types of things, from what I read in your book, that's analogous to what astrophysicists are doing as well, just thinking about the meteors and so forth. So that just led me to the question, should the intelligence community be looking out into the universe and into space to do more of this stuff? Because at the minute it's very terrestrially confined, or even the National Reconnaissance Office or the National Geospatial Intelligence Agency, they're looking at, satellites, low Earth orbit, near Earth orbit, all those types of things. So should their gaze be wider? Should they be, rather than focusing on national security, should they be focusing on planetary security? Or would your advice be just leave it alone? Whenever you guys get involved, it always gets a bit weird. Let the scientists do their work, and we'll try to figure it out eventually. I'm just wondering what your thoughts are on that.
Right. So I met Avril Haines, the director of national intelligence, in the green room of the Washington National Cathedral at a public gathering that included Bill Nelson, the head of NASA, and Jeff Bezos. And I asked Avril, since she has a bachelor's degree in physics from the University of Chicago, I approached her as a physicist and I said, Avril, you just reported to the US Congress, that was back in 2021. You reported about those unidentified objects. What is your gut feeling? What are they? And she said, I don't know. And I believe her. I think we need more data. We need to examine it more carefully. And I do think that scientists can help the government figure out what is out there, and it's to the benefit of both communities. Scientists, of course, have a broader knowledge of what lies beyond the Earth. For matters of national security, I'm not so worried about visitors from far away, the interstellar space, because my view is that we are not that important. If they arrive here, it's for other reasons. And the benefit is all ours because they arrived at our doorstep before we managed to arrive at their doorstep. And that means they're far more advanced than we are. We just had the benefit of about a century of modern science and technology. Quantum mechanics was discovered just a century ago. And the gadgets that the two of us are using to communicate right now, they're all based on this understanding of quantum mechanics, electronics, that resulted over the past century. Now imagine another civilization that existed with modern science and technology for more than 1,000 years, 1,000,000 years, maybe even 1,000,000,000 years. They would be so much more advanced than we are. We are thinking about ChatGPT-5 as exceeding the number of synapses in the human brain with its number of connections. So we will develop an artificial intelligence system that would be more capable than the human brain on some tasks. But this is just within a century of starting modern science and technology. And it's hard to imagine what the next century will bring and the next 1,000 years would bring. But if we encounter a more advanced neighbor, we could get a glimpse at our future technologies. And we will greatly benefit from that. That will provide us with a quantum leap if we are able to understand how things work. We will get a better sense of physics and a better sense of questions that we have no answer to as of now. How to unify quantum mechanics and gravity, perhaps. And that would be, of course, of benefit to anything to do with national security. But more importantly, it will give us a new perspective about our place in the universe. And perhaps convince us that, fighting with each other here on Earth, currently there are 2 wars going on. We spend worldwide $2 trillion a year on military budgets. If we were to invest those funds in space exploration, instead of wasting them on killing each other, we could reach, or we could send a probe towards every star in the Milky Way galaxy, tens of billions of them, within 1 century. It's just a matter of priorities. And my hope is that realizing that we have a smart neighbor that we can learn from would convince us to change our priorities from fighting over territories on this small piece of rock, trying to kill each other, to something more noble, just looking up and having bigger aspirations, because there is so much more real estate out there than you find here on Earth.
We'll be right back after this quick break.
And now, a word from our sponsor, Zscaler, the leader in cloud security. Cyber attackers are using AI in creative ways to compromise users and breach organizations. In a security landscape where you must fight AI with AI, the best AI protection comes from having the best data. Zscaler has extended its zero trust architecture with powerful AI engines that are trained and tuned by 500 trillion daily signals. Learn more about Zscaler Zero Trust Plus AI to prevent ransomware and AI attacks. Experience your world secured. Visit zscaler.com/zerotrustai. And now a word from our sponsor, SpyCloud, the leader in operationalizing cybercrime analytics. Traditional threat intelligence is a thing of the past. Cyber criminals are stealing vast amounts of credentials, session cookies, and financial data every day, and it's hard to keep up. SpyCloud is the trusted partner businesses turn to fully understand their darknet exposure risk and neutralize threats before it's too late. SpyCloud alerts your organization as soon as an employee or customer's data appears on the dark net, so you can act faster than bad actors to prevent cyber attacks like ransomware, session hijacking, account takeover, and online fraud. With insights from the industry's largest repository of recaptured data, protect the digital identities and systems most important to your business. Get your free corporate darknet exposure report at spycloud.com/cyberwire and see what information criminals have in their hands today. That's spycloud.com/cyberwire.
There's a nice phrase that I took out of the book. You call it the parochial practice of industrialized murder. When you think about the nature of what's out there in the broader sense, it really brings home the insignificance of this piece of planetary driftwood swirling around in space. It's quite humbling reading about the research that you're doing.
It is very humbling. I mean, and that should be the perspective we take, because I'm invited to give the keynote speech at the celebration of 550 years to the birth of Nicolaus Copernicus. The government of Poland invited me, and I decided to speak about the next Copernican revolution. The first Copernican revolution that Nicolaus Copernicus came with was to recognize that we are not at the physical center of the universe. And I think the next one would be to realize that we are not at the intellectual center of the universe. And, it will just fill us with awe towards a much more sophisticated neighbor that we might have and can bring us together. That's my hope. Actually, it's ironic that the day before I go to Poland, I will be in Munich at the Munich Security Conference, which is a gathering of heads of states and senior officials, including from the White House and many other countries. And there I will be speaking about unidentified objects, the Galileo project, to people who are mostly occupied with national security concerns. And a day later, I will go to Poland to speak about the next Copernican revolution, which is really what I hope for in the coming years. And of course, to gain new knowledge, we have to work hard at it. We have to invest funds in the research. People say extraordinary claims require extraordinary evidence. And I say extraordinary evidence requires extraordinary funding.
Just for our listeners, I know this is a very difficult question to summarize, but what's the existing theoretical take on what's out there? Is there a scientific consensus or a paradigm just now, or is it still being resolved and struggled over?
Well, it depends who you ask. So the scientific community that makes the official statement that we should not include the search for intelligence as part of the mainstream research in astronomy. And that's because it may be speculative. Perhaps we are alone. We didn't get yet any evidence that we are not alone. We didn't detect any radio signal. Enrico Fermi said, "Where is everybody?" Therefore, that should be regarded as a speculation. So the mainstream view that you will hear is that it's very possible and likely that there is nobody like us. And that was obviously the view before Copernicus, before Galileo, that we are at the center of the universe, the physical center. So we are extremely important. Here it comes again. Okay, we are not at the center, the physical center, but we are still unique and special. And I can understand where it's coming from, because when my two daughters were young, they thought that the world centers on them. And they did it because they have limited experience. They only saw their immediate environment and all the attention that is given only to them. But as soon as they went to the kindergarten and met other kids, they realized they had a psychological shock that they are not the only ones and that there are others very similar to them. Now, to me, this sounds like common sense, that you should start from the assumption that you are not unique and special. But instead, the mainstream of astronomy starts from the opposite assumption. And you may ask why. It doesn't make sense to argue that we are unique and special when we see stars like the sun having planets like the Earth roughly at similar separations. There was just a news story today about a super Earth that was detected in the habitable zone of another star. And so we know that there are plenty of systems of planets in the habitable zone of stars, maybe tens of billions of them in the Milky Way galaxy alone. There are trillions of galaxies in the observable volume of the universe and many more beyond the horizon of the cosmos. So altogether, the numbers are huge, and it's really arrogant to believe that we are unique and special given those circumstances. And nevertheless, the argument is made, we haven't seen them yet. But of course, this is a circular argument. If you don't search, you don't invest the effort, you will never find the evidence that you're not. It's just like a single person standing at home and saying, there is no partner for me. But obviously, to find a partner, you really need to go to dating sites. You need, at the very least, to look through your windows and search for partners. You can't just say there is nobody next to me, the way Enrico Fermi argued in Los Alamos 73 years ago. We don't know if they exist. Nevertheless, the mainstream prefers to hang on to these notions just in order not to even consider the possibility of an artificial object. And I say that is not, the beginner's mind that one should have.
You've put yourself out on a limb a little bit by saying, listen, the scientific consensus is not what it should be. The dating analogy, like at least brush your teeth and have a shower and go out to a bar or something and see what happens. So I'm just wondering, do you feel like you're out on a limb? Are your arguments getting traction, or how is that all panning out within the field?
Important element of science, and that is really key, is paying attention to evidence, not to opinions. Now, what happens very often is people are not seeking the evidence because they have an opinion. And then you have a consensus. I asked my research group what makes theoretical physicists happy. And there was silence in the room. And then I gave the answer: lack of evidence. Why? Because then they can maintain their opinions. The whole beauty of science is that you can have theoretical ideas, but then you put them to a test. And the guillotine of experiments very often chops the head of ideas that do not describe reality. That's the way science makes progress. So it's not about consensus, because consensus can be maintained forever if you are not seeking evidence. Very often what happens is they are so convinced of the idea that if someone else tries to collect evidence and it doesn't conform with the idea, they will brush the evidence aside, ridicule it, step on it, so nobody would notice. If you are a scientist, you recognize that how often this happens, where you have bubbles, basically a group of people that divorces its set of beliefs from experimental testing. And in some cases, it could be for your entire life, your entire career. If you consider string theorists, for example, they have been promoting ideas about additional spatial dimensions for, by now it's 40 years. We haven't had a test of that demonstrates it. We might not have a test of that during their lifetime. And that's what makes them happy, because they can continue to go to conferences and do intellectual gymnastics. And you would argue that's the mainstream view in theoretical physics right now. But is that really what describes reality? We don't know. We haven't made any significant advance at developing a theory that unifies quantum mechanics and gravity, that makes predictions, that can explain how the universe started.
I'm also just thinking about analogies with the intelligence community, because obviously empirical evidence is an important part of that, but sometimes you don't have all of the information, so people have a hypothesis or a theory about what's going on and so forth. And
yeah, because it motivates you to get more evidence. So that's extremely important. So sometimes, as you say, most of the time you don't know the answer, and you have a variety. So you come up with alternative explanations, alternative interpretations. You have to put all of them on the table. And as Sherlock, it's just like a detective story. Sherlock Holmes used to say in the fictional book that you need to eliminate all possibilities, and whatever remains must be the truth.
I have this quote from John Ratcliffe that you mentioned in the book, so former Director of National Intelligence, and he says, "Frank, there are a lot more sightings than have been made public. Some of those have been declassified." So what I'm asking, and I don't know if you know this, but how much attention do the intelligence agencies play towards this stuff, other than, the X-Files or stuff that we see in culture, like the intelligence community, Avril Haines, John Ratcliffe? Is this something that's peripheral to the intelligence community? Are their views being changed by legislation coming out of Congress? So you mentioned Harry Reid in the book and so forth. Help me understand how much this is within the wheelhouse of, say, American intelligence.
When you hear the Director of National Intelligence, either Ratcliffe or Haines, speaking about unidentified objects, there are two possibilities. One is that they are not doing their job, that these objects are made by adversarial nations and represent technologies that we have no idea about. Because if these objects were representing technologies that are obvious for us to interpret, then they wouldn't talk about them as unidentified. So it's possible they don't have enough data to figure it out, but that's very alarming because it means that they're not doing their job. They are supposed to figure out any threat to national security, and here are a class of objects. Maybe a few percent of those. There is the Old Domain Anomaly Resolution Office that was established by Congress as a result of the reports from Avril Haines. And the bottom line as of now is they identified 97% of these objects, but 3% remain unidentified. And I would be very alarmed if I was in Congress or in the intelligence agencies, because a few percent, this could be a large population of objects that we just don't understand. So someone has to figure it out if it's a matter of national security. The second possibility is even more alarming. It's something that was not made on this earth. Okay? And then, of course, it's an issue that should be studied by scientists. So I think this subject should get a much higher priority than it gets. Because in the first case, you start worrying about, there was the Chinese balloon that was shot down a year ago, and perhaps there are more objects that are spying on the US and that we are not aware of. We need to find out. But if that's not the case, and that was the hint that was given by Radcliffe, he said that there are satellite images that show objects that are quite puzzling. Avril Haines reported in 3 separate instances about the objects that the intelligence agencies cannot identify. So, I say that if this is not national security related, then please tell me more. Because as of now, I don't know what the data shows, and I would be happy to help government figure it out. And of course, we're trying to do the work through the Galileo project, but it would be far more efficient if we were to partner with those who have access to this data and recognize that it's not a matter of national security.
And just as we get towards the end of the interview, I just want to give our listeners a sense of looking out to the stars. So we're also busy going through life, just looking at our day-to-day or looking at this planet that we inhabit. Give them a sense of the scale of this. Like, how would you bet money that... it seems to me after reading your book that it would almost be strange if there wasn't another life form somewhere within the vastness of the universe.
Sure. There are hundreds of billions of stars like the Sun in the Milky Way galaxy alone, and trillions of galaxies in the observable volume of the universe. So the size of the observable universe is a quadrillion times bigger than the Earth-Sun separation. Quadrillion is 10 to the power 15. So it's 1 with 15 zeros after. And that's how much bigger is the size of the observable volume of the universe. Now, as far as we can tell, there is no cliff near the cosmic horizon that we can see. So in fact, based on the data that we have on the universe, we can tell that the same conditions persist at least 4,000 times farther than we can see. So, in fact, you have a volume that is 4,000 cubed times bigger, at least, that contains even more galaxies than we can see with a Webb telescope, for example. So it's just such a vast ocean of space. And, we are in this tiny boat sailing in this ocean of space. We think that we are unique and special on this boat. And I say, just look out, with telescopes. You might find other boats around eventually. It's the natural thing to expect. And most of the stars formed billions of years before the Sun. And it takes less than 1 billion years to cross the Milky Way galaxy from one side to the other side with the chemical rockets that we launched already, with spacecraft like Voyager, Pioneer or New Horizon. It will take 1 billion years for those to cross the entire Milky Way from one side to the other. And given that other civilizations may have preceded us by more than that, they had enough time to reach to the solar system by now, and we should just search for them.
That's it for T-Minus Deep Space, brought to you by N2K Cyberwire. And may the 4th be with you, and also with you. You'll find more of Avi's chat with Andrew on the Spycast podcast and at thecyberwire.com. We'd love to know what you think of this podcast. You can email us at space@n2k.com or submit the survey in the show notes. Your feedback ensures that we deliver the information that keeps you a step ahead in this rapidly changing space industry. T-Minus Deep Space is produced by Alice Carruth. Our associate producer is Liz Stokes. We're mixed by Elliot Peltzman and Trey Hester, with original music by Elliot Peltzman. Our executive producer is Jennifer Iben. Our executive editor is Brandon Karp. Simone Petrella is our president. Peter Kilby is our publisher. And I'm Maria Varmazis. Thanks for listening. We'll see you next time.